Yeah, my name is Hexadecimal, popularly known as Dana David. Welcome to another class on binomial. Dimensional. Okay, binary.
Start again.
Okay.
No, don't stop. Just pick it up.
My name is Hexadecimal, popularly known as Dana David. Welcome to another class on binary conversions. The conversion between, we have the binary, we have the octal, we have the decimal, and we have the hexadecimal. Now, if you're talking about the binary is to the base of 2. Octal is to the base of 8. Decimal is to the base of 10. And hexadecimal is to the base of 16. So we check very well. Now, if we are talking about the conversion between these, we have to examine some things. But this time around, we'll be going straight to the conversions on the calculator. And at the same time, we will be using the AND method first in order to show just only one question. I'll be showing one question using AND method. Then from there, we are going to move straight to the calculator method. Now, imagine you are asked to convert something like maybe 1101 base 2 to decimal. Convert this to decimal. You know, that shows you are asked to convert from binary to decimal. Now from this binary to decimal, you are going to use this shortcut that is the AND method. You add 0, 1, 2, 3. So we now multiply. So this becomes 1 multiplied by 2, the first one raised to power 3, plus 1 multiplied by 2 raised to power the second one, which is what, 2, plus this one is 0. 0 multiplied by 2, the raised to power was 1, plus the next one is what, 1 multiplied by 2 raised to power 0. Then if you check very well, 2 raised to power 3 will be 8. Then times 1, that's 8, plus 2 raised to power 2, that's 4, times 1, that's 4, so that's plus 4, plus this one is 0 because 2 raised to power 1 is 2, multiplied by 0 will be 0. And 3 raised to power 0 is 1, times 1, that's 1. So we have 0 here, and we have 1. So the final answer to this, you have 8 plus 4 to be 12 plus 0 plus 1, that's 6, equals to 13 base 10. 13 base 10. Now you can just do this on your calculator. Now, how do you do this on the calculator? The first thing you are going to do is that you press your mode. Now when you press your mode, you observe that you have in number 4 of your modes to be base n. You see something like base n? And when you press that base n, it will give you 0, 0, 0, 0, 0, 0, 0, 0. But you notice, you have 0, you have decimal, you have 0, and you have decimal, something like this. Now, don't forget that we are to convert from binary to decimal. And it shows on your calculator decimal. So we have to take our calculator to binary first. Now, how do you take your calculator to binary? Now, when you observe that under your mode, you have something like x to the power minus 1. Now, when you check around that page, you are going to see something like dec. Underneath, you are going to see something like x. You are going to see something like bin. You see ox there. Now, you don't need to press shift or alpha before you press this thing. Once you've taken your calculator to base number, then you just be pressing the button. You observe that the button that entails this deck is the one that has x to the power 2. The button that has this x is the one with x raised to the power. The one that has this binary is the logarithm button. And the one that has this oct is the natural logarithm button, which is ln. Now, so press the button for the binary, that is your log. When you press it, you observe that it takes your calculator to binary. You have 0, 0, 0, 0, 0, 0, 0. You have binary. Then, let us press the question given to us, and that is 1101 So when you press 1101, then press equals to. You make sure that before you convert to where you are asked to convert to, it firstly reflects at where you want to take it from. What did I mean? Now, if you want to cross from a place to another, you must definitely show in the place you want to cross before you appear in the other end. So that is why this thing must show. That's why we press equals to. You observe that the value shows at the binary here. That is why at the binary you have 1101. So it must show at the binary before you now convert. So after it shows like this, then press the button of deck. When you press the button of deck, you observe that your answer is 13. It shows, which is equals to what? This. So you convert this binary to what? To decimal using that calculator method, in which you get the answer to be 13. Don't forget, the principle we are following is that you will definitely have to first let the value to show in the current state or in the correct base, then before you now take it to the what? To where you are asked, to the base at which you are asked to convert it to. So that is the principle. Now let us look at another case. Now, if you are asked to sum binary, let's say you are asked to sum binary. Now, this is the only hand method I will be doing for now. This is the only hand method I will be doing for now. Now, if you are asked to sum binary, you don't have to give yourself issue. Just let us press AC so that your calculator will be at the what? At the deck. Now, if you are asked to sum binary, let's say for instance, you are asked to find 110 plus 11. You don't need to give yourself issue. Just press the binary button, which is log. Now, when you press the binary button, you now press the question given to you. That is 110 plus 11. Just press this straight. 110 plus 11. After your calculator is in what? Is in binary. So then press equals to. You observe that the answer here is 1001 to the base what? To the base 2. Let's see multiplication. If you're asked to multiply binary numbers. Now, if you have something like 11 multiplied by 10. If you are asked to multiply this as well, press AC. When you press AC, you observe that the calculator is still in binary. And if it's not in binary, take it to binary. Now, if it's in binary, then press the question you are asked to multiply, in which you have 11, then multiply by 10. Press equals to, you observe that this value is 110. Or you start from 0, 110. You understand? Now, because it contains 4 numbers, so you can have it to be 110. So, and even if you check this very well, it is 110 to the base of what? To the base of 2. To the base of 2, 110, which is the multiplication. The same thing goes with subtraction. If you have to subtract, this is how you are going to do it. Now let us advance a bit. Now, if you are asked to convert something like this, 162. Convert 162 base 10 to hexadecimal. Convert 162 base 10 to hexadecimal. How are you going to do it? Press your AC. When you press AC, you'll notice that your calculator is a binary. But don't forget, this where we want to convert from is decimal. So you are converting from decimal to hexa. So press your decimal button. Make sure that your calculator is in what? Decimal button. And that is x raised to power 2 button. Now when you press that, you now press your what? Your value of the decimal you want to convert. And that's 162. So when you press 162, press equals to, you observe that the 162 appears under the what? Under the decimal. This is where you want to convert from. Now when you want to convert from this, then where are we converting it to? We are converting to hexadecimal. Then press the button of hexadecimal, which is the x raised to power the power here. So you observe that the answer here in hexadecimal, it is equals to A2. So this is the final answer, A2. So A2 is the conversion of this to what? To hexadecimal. Now let us convert. This is how you do the conversion. Another question is that convert. Let me give you something like 0, 1, 1, 1 base 2 to octal convert 0111 base 2 to what? To octal. So press AC. When press AC, now let us go. You make sure that this is in binary. So let us take this to binary. So press the binary number, which is the log. When you press the log, when you press the question, which is 0111, then press equals to, you make sure that it shows at what? At the binary digits there. Then when it shows, then convert to octal. How do you convert to octal? Just press the button of what? Of octal, which is the lane button. Now when you press the lane button, when you convert, you observe that this one is equals to 7 to what? To base 8. You know, it's equals to 7 in what? In base 8. That is what? Octal. That is octal. Now let us advance a bit. They can just ask you to convert a decimal number or a binary to anyone but C. Let me give you another case entirely. The case I'm talking about, if you have something like 0.1 or 0.685 base 10, that is decimal, to binary. 0.685 base 10 to binary. Now, if you are asked to find this one is different from those ones we've been doing before. You observe that this is decimal, but at the same time, it contains decimal points. It's contained decimal points. It's contained decimal points. So how are you going to do this on the calculator? Just what? Just press. Everybody reset your calculator. When you set your calculator, how do you reset calculator? That is, you take it out from binary. It is either you press mode and you press comp. It is either you press mode and you press comp, or you press shift 9, 3 equals to twice. It is either you press that. Now, when you press this, when you've reset your calculator, then you make sure that you press the question. How do you press the question? Just press 0.685. When you press 0.685, now don't forget that we are taking this to binary. Then how do we get this in binary? Then press multiply by. When you press multiply by 2, it is constant. You press multiply by 2, then press raised to the power. When you press raised to the power, after you press raised to the power, then we will now count how many number is at the back of this. That's 3 number, 1, 2, 3. So press raised to the power 3 like that, then press equals to. Now after you press equals to, you observe the answer, but I don't care about the answer. So all you need to do is that press your mode straight up. When you press your mode, then press your base number. When you press your base number, you observe that the previous operation that we did, which is this one, the answer you have, just press answer on your calculator, which is the button below. You see this button, answer, then press equals to. You observe that this answer will show as the what? At the decimal button. And what you have is what? Is 5. Now when you have this 5, the only thing we need to do is to convert this decimal 5 to what? To binary that I want to convert it to. So that definitely press your binary button, which is log. Now when you press the log, you observe that you have 0.0000000 something like that. Then what? You have 101 ending this. Now how will you know the correct answer? The correct answer for this operation is that you now count how many number do you use here. The power you use here is what? Is 3. So now from that 0.000000000, you know you have a lot of 0 before you have the what? The digits here. All you need to do is that count from behind the number you use as the power. Then that is where you are going to place your decimal points to. Then we have 1, 2. You have 1, 2, 3. So that means the decimal point will be in between here. That is why the conversion of this is 0.101 to the base of what? To the base of 2. And this is how to convert a decimal point decimal to what? To binary. To binary. Now, let us do from this binary. You know, there are some binary that that will contain decimal points. Now, let us do that. Now, imagine you are given something like this. Imagine you are given something like 0.1011 base 2. Then you are asked to convert to what? To decimal. You are asked to convert to decimal. 0.1011 base 2. You are asked to convert to decimal. Then the only thing you need to do here is that, okay, this one is now the inverse of the process we followed the other time. You know, the other time we firstly multiply, then we'll now take it to what? To binary, to convert. But this time around, you firstly take your calculator to binary. So make sure that your calculator is in what? Is in binary. So that means you have something like this. You have your binary. That is, your calculator must be in binary at this stage. You know, in the previous stage, we start from the what? By clearing the calculator out of the base number. But this time around, you start from the base number. So your calculator is in binary. Then press this without pressing the decimal point. Without pressing the decimal point, that is, you press 01011. Without pressing the decimal point, you press 01011. Then press equals to. You will observe that this will shows at the what? At the binary here. Now, when you have it at the binary, then press the decimal button because we are trying to convert to what? To the decimal. Then when you press this, you observe that the decimal here is equals to what? 1. But that's not the final answer. Now, after getting, 11, we got 11 for the decimal. Now, after getting 11, then you now take your calculator out of the binary. So you reset your calculator. When you reset your calculator, you take it out of the binary, that is out of the base number. Then recollect that the value you got from here, which is 11, so press 11. After you now press 11, then press divided by 11. This value you get, then divided by 2, then raised to the power of. Now, what is the number after the decimal point? And that's 4. 1, 2, 3, 4. So that means we now have it to be raised power 4. So you have 11 divided by 2 raised power 4. Then press equals to. You observe that the answer here is 0.6875 to the base of what? To the base of 10. So this is how to convert from binary to decimal and from decimal to what? To binary. For those of the question that contain decimal point. If the binary contain decimal point, this is how to do. If the decimal also contain decimal point, this is how to go about it. Now let me give you an exercise. Let me know. Now the first one, or let us do another one. Press AC. Press AC. Let us go for another one. Now if you are asked to convert something like this, convert 0.1101 base 2 to decimal. Now, this is what I'm going to do for the sake of those that don't understand the previous one. Now, we are going to convert this to decimal, and at the same time, we are going to convert our answer to binary back. And let us go with that. Now, the first step, you know, is that you are going to take this to binary. If you want to convert from binary to decimal, press your mode. When you press your mode, then you press your base number, which is number 4. When you press that, you observe that it's in deck like this, which is you have 0, but it is the binary that you want to press. So press the binary button, which is log. Now when you press the log, it will change here. Then press the value you have here without pressing the word, without pressing the decimal point, in which you press is 01101. Then press equals to. You observe that it shows at the words at the binary value here. Now after getting that, the press decimal point you want to convert it to. You observe that what you have for the decimal there is equals to what? 13. Then reset your calculator. You press shift 9, 3, then equals to twice. But make sure you jot in the word, the value you got for the word, for the decimal. Then take your value, which is 13. Don't forget the process is that you now press that value of decimal, then divided by where you are converting it from. That's base 2 now. So press 2, divided by 2, then raised to power. How many number is behind or after the decimal point? That's 4 number. So that means it will now be raised to power 4. Then press equals to. You observe that the answer here is equals to 0.8125 when you express in decimal. Don't forget we have a button here, which is SD button, because SD button is above AC. You know the AC button. At the top of the AC button, you are going to see SD button. If you see any fraction button or any fraction value rather, then you can convert to what? To decimal. Or you press it again to convert to what? to fraction. Now, this same value is 0.8125 base 10, which is decimal. Let us convert it back to what? To binary. So the thing is that you press your AC. So when you press your AC, don't forget, if you want to convert from decimal to binary, you firstly press the value given to you. So in which you have 0.8125, you press 0.8125, then this time around it will now be what? Multiply by 2, then raised to the power of the value you use, don't forget, is the number after what? After 0. And if you check, the number after 0 here is what? Is 4. Then press equals to. Now when you press equals to, you have the answer to be 13. Then press AC. When you press AC, press your mode, in which you have your base number to be what? Number 4. So when you press that, then press your binary. Sorry, you still leave it in decimal because the value we got here is 13, which is the value for what? For decimal. So press answer and press equals to. You observe that the value will show, after you press answer here, the value will show at the what? Under the decimal like this. Now once the value shows, then press your log, so that it will, that is the log that contain what? That contain binary. So when you press that log, it's not take it to what? To binary. If you observe, you have 0, 0, 0, 0, a lot of 0. Then you have 1, 1, 0, 1. Then how will you know this? You now check the number you use here, which is 4. So you now count from behind this one. That's 1, 2, 3, 4. So that means the 0, the point is here. That means you now have the answer to be 0.1101 base 2. So we've been able to convert from this 0.1101 base 2 to this. And we've been able to convert from this back to what? Back to 0.1101. And I believe with this, we've been able to cover a lot about the conversion from hexadecimal to octal, from decimal to binary, from binary to octal, and from binary to decimal. So please let me just give you a question, then let me know the final answer at the comment section. Now, convert this, convert 2.145 base 10. Then convert this to binary. Convert 2.145 base 10 to binary. Then let me have the final answer. Thank you very much. Like, comment, and subscribe. Thank you very much.